All right, welcome. Today, we are going to pull back the curtain on the apps we use every single day. We're going to break down piece by piece how a modern application is actually built, from the button you click on your screen to the super complex stuff that happens miles away on a server. So, let's get into it.
Seriously, think about it for a second. You see something you want online, you tap a button, and poof, it's in your cart. It feels completely seamless, almost like magic. But that single click, it's really the starting pistol for this incredible, high-speed race happening completely behind the scenes. Yeah, that one little action sends a request flying from your browser through a whole ecosystem of different technologies. You've got the front end, the back end, databases, maybe even some AI. All of them have to work together perfectly to make that simple click feel, well, simple.
So in this explainer, we're going to follow that journey from start to finish. We'll kick things off with the front end, the stuff you can actually see. Then we'll dive behind the curtain to the back end, where all the logic lives. We'll look at how it juggles data and even how it uses AI to think. Then we'll see how the whole thing is packaged up and sent out into the world. And to wrap it all up, we'll talk about how this has totally changed what it even means to be a developer today.
Okay, first stop on our tour, the front end. This is everything that you, the user, can see and interact with. It's the buttons, the menus, the images. It is the visual world of the app. Now, if you rewind the clock a bit, websites were kind of clunky. You'd click on something and the entire page would have to go white, then completely reload. But modern apps, built with tools like React or Angular, are way smarter. They're built from these dynamic, independent, and reusable things called components. So what's a component? Honestly, the best way to think about it is like a digital Lego brick. A search bar? That's a component. A profile picture circle? That's another component. A like button? You guessed it, a component. Each one is its own little self-contained package with its own design and its own logic. Developers build all these little bricks and then they just snap them together to build these really complex and interactive experiences.
Okay, so you've clicked a button on the front end. A request has officially left your computer. So where's it going? It's zipping across the internet to the back end, which is kind of like the hidden engine room of the whole operation.
The back end is where all the real heavy lifting happens. It handles the important business logic, it checks if you're logged in, it processes your payments, it talks to the database. It's the part of the app you never, ever see. But trust me, without it, nothing would work at all.
Now, a really popular way to organize all this back-end work is a pattern called Model View Controller, or MVC, and the restaurant analogy here is just perfect. So first, the controller is like your waiter. It takes your order, your request, from the front end. The waiter then gives that order to the model, who is the chef in the kitchen. The chef, the model, gets the ingredients, prepares the dish, handles all the logic, and finally, the model hands off the finished dish to the view, which plates the food beautifully. It generates the final HTML that gets sent all the way back to your browser.
But for that backend to do its job, it needs information. It needs to talk to other services, access huge amounts of data, and sometimes it even needs to, well, think. And that's where data formats and AI enter the picture.
So how do all these different parts, the front end, the back end, the database, talk to each other? They need a common language, right? Well, on the modern web, that language is overwhelmingly JSON. It's just a super simple text format that uses these key value pairs. It's really lightweight, it's easy for humans to read, and it's easy for computers to understand, which makes it the perfect universal language for the entire application. Okay, so storing and grabbing data is one thing. But what if you want your app to do more? What if you want it to actually think? Like, say you're building a support chatbot that needs to answer questions using your company's internal documents. How do you give an AI its own custom brain?
Well, you can do this with a process called Retrieval-Augmented Generation, or RAG. It sounds complicated, but the idea is actually pretty straightforward. First, you load up all your custom documents, product manuals, company info, whatever you want the AI to know about. Then, the system splits all that text into smaller chunks and embeds them, which is a fancy way of saying it turns the words into numbers, or vectors, that an AI can actually understand. Finally, when a user asks a question, the system retrieves the most relevant chunks of that vectorized information and feeds them to the AI, which then generates a really smart, context-aware answer. It's not just repeating things, it's reasoning based on the knowledge you gave it. It's pretty amazing.
So at this point, we've got our front-end components, our back-end logic, our AI brains, all the pieces are built. The big question now is, how do we package this whole complex system up and get it out to the world so it works reliably for everyone every single time?
Ah, yes. This is maybe the most famous and frustrating phrase in all of software development. A developer swears the code works perfectly on their laptop, but the second you try to run it anywhere else, it just breaks. This used to be a massive, massive problem. The solution to that headache is something called containerization, and the king of containerization is Docker. The best analogy is a real-world shipping container. It doesn't matter what you put inside it, and it doesn't matter if it's on a ship or a train. The container is standardized and works everywhere. Docker does the exact same thing for software. It bundles the app and everything it needs into one standard box that will run the exact same way no matter where you put it. So what's actually packed inside one of these Docker containers? Well, it's the whole shebang. You've got a basic operating system, all of the application's source code, every single library and package it depends on, and finally, the exact instructions on how to start it up. And all of this is defined in a simple little recipe file called a Docker file. It's the complete, self-contained package. So when you step back and look at all these pieces working together, these dynamic front ends, these complex back ends, the AI models, the Docker containers, it becomes pretty clear that the job of a software developer has fundamentally changed. It's not just about sitting down in a dark room and hammering out lines of code in one language anymore.
No, the modern developer has become an architect.
Their most important skill now is understanding this entire ecosystem. They're systems integrators. They have to choose the right tool for each part of the job. Maybe React for the UI, ASP.NET for the backend, LangChain for the AI, Docker for deployment, and then skillfully weave all those pieces together into one single powerful application.
We've really shifted from building everything from the ground up to assembling these incredibly sophisticated systems from powerful specialized parts. And that shift has just unlocked a level of speed and power that we've never seen before. So really, with this whole universe of tools at our fingertips, the only question left to ask is, what will we build next?